All right, so in the last example, we found a local maximum and a local minimum. But we have to be careful. Not every critical point of a function is a local maximum or a minimum. All right, and example 4 is just illustrating that. So if we take this function, f of x is equal to x cubed, the derivative of it, f prime of x, is equal to 3x squared. And if we set that equal to 0, we can find that we have a critical point at x equals 0, right? Because when x is 0, the derivative is 0, right? So that's telling us the slope of the function is 0 at that point. But if we evaluate points on either side, so let me draw my little number line, and my critical point is 0, so I want to test points on either side of 0. Now, if I look at, say f prime of -1, right? That's to the left of 0. What do I get? I put in -1, I square it, I get +1, right? -1 times -1 is +1, and then times 3, right? So I get a positive value, right? So it's greater than 0, which tells me that my function is increasing. Now, if I look at a point to the left of 0, or sorry, to the right of 0, so like f prime of 1, so I look at the derivative, I'm looking at the slope, plug in 1, square it, and take it times 3, I get 3 again, which is again greater than 0. All right, so again, it's increasing. So even though the slope is 0 at 0, it's increasing on either side of it. And so this is neither, this critical point, x equals 0, is neither a local maximum or a minimum. All right, so if you, and you can tell if you look at the graph of the function, if you look at the graph of the function, if you know what x cubed looks like, it's, it looks something like this. It kind of flattens out here, and then it keeps going. So this is the graph of x cubed, right? F of x is equal to x cubed. This is x cubed. And you can see you've got a point in here somewhere where the slope is 0, but it's increasing on either side, so it's not a maximum or a minimum. All right, so I will meet you in the next video.